C,
How did you come up with C?
because 24 was the closest to when the line reached its like average again.
Okay. So this one though is asking not when it not when it asked from when it ended, from when the period ended. And it if you so and that's where you need these two numbers. And I know I say it's not useful, but of course there's an exception to everything. Um, so it's basically saying like, what's the window from here to about there? What is this length? And I agree, it is 24, but that's not from when it ended. How many minutes passed from when the period ended to when it heartbeat?
9.
9, yeah. Okay.
Oh, okay.
It's one word, right? One little word made all the difference.
Yeah.
All right. Let's look at another one here. Right, which scatter plot could represent these data? So let's go back and see what kind of data are they representing. The relative yield of corn expressed as percent in soil were recorded for 5 samples. For the 5 samples, the relative yield of corn reached a maximum when the pH had a level of 6.8 and then decreased. So which of these could it be? Which reached a maximum at 6.8?
C.
C is a pretty good option. Why? Yeah, I mean, it's the only one that actually has the true maximum there. So the that is the correct answer. These probably aren't exactly the ones that you're looking for as far as graphs, but is this okay that we're doing these types of problems, or do you want to try something
Yeah.
different? Okay. These are the intermediate difficulty, by the way, on this, so they don't get a ton harder than this point.
D.
Why is it? You said, I'm sorry, did you say D like dog or B like boy?
D. Like dog.
D. Yeah, got it. Okay. Yes, that's correct. All right, good job. Sometimes just doing these problems, it helps to remind you, okay, yeah, that's the slope, that's the intercept. This one's about increasing and decreasing, which is something you've covered in your course. They don't, it's not like it's not a detailed question like here. Um, you're looking at here, but go ahead and take a look at this one, please.
B.
Okay, 5 and 6. So it's basically asking which is the steepest, which is right in here. I agree with you on that. All right. Let's go and look at another one. Okay. Yeah, take a look at this one. We're looking for the not true one. That's always a little different.
B.
Teresa's speed was increasing for a longer period of time than it was decreasing. So that means the others must be true. Is that what we're saying?
Yeah.
So I agree that one's true. Teresa's speed decreased at a constant rate during the last 5 minutes. That's true. Teresa's speed reached maximum during the last 10 minutes. That is also true. So yes, the answer is B. Always, always have a way to work through those not trues, however you decide. It's a reminder that, okay, there's 3 that are true and that problem. Okay. Last one before we switch to something else here.
C.
Right, so that means the third one is not showing a decrease each time, colony C.
Yeah.
So is that that's true. So every 2 weeks after the initial treatment. So like to me, what we're looking for, C is the black one. To me, that goes down each time. Maybe I'm missing something there. Um, the
But it
oh, I see.
starts
Oh,
down.
I see. I see what you're saying. I misinterpreted this. Um, decrease. Yeah, yeah. Okay. So you are correct. Matthew's wrong. All right. Good catch on that. All right, so those are called scenarios or modeling scenarios. Most of them are linear. They have a few nonlinear ones, but one of the things I'll just quickly remind you of before we go to polynomials, I did find some graphs of that, is R regression values. So if the data is going up and to the right, R is positive. You remember what I mean by R? That's the correlation coefficient. And you can just remember that it goes the same direction as the slope. So R positive when it goes up and to the right. If the data goes down and to the right, that's R negative. And then
Okay.
if it's just kind of going horizontal or it's all over the place, R equals 0. They've been emphasizing more on this regression stuff. And again, this is like, again, one of those pieces of information. It's like, I don't know if it'll be useful or not. You could get one question that requires you to remember this.
Okay.
Right. So let's go and look at some polynomial stuff. Um, let's just get through some basics here. What is f of 0? What does that mean in a polynomial? You remember anything about that?
What? Oh, the Y value?
The y-intercept, yeah. And what is it when f of x equals 0? What does that mean?
Y equals 0.
These are the x-intercepts, or the roots, or the zeros, or the solutions. Okay, so they're very different, but just keep that in mind. So I was wrong there. I found one little thing of questions that I have on polynomial graphs. So maybe you'll get one, right?
Hmm.
But that could make the difference. That could be the scholarship. That could be the getting into the university. So, all right, see if you can answer this one on your own, please.
Is it D?
So it's definitely not C. Hopefully that came about. Before I
Yeah.
answer that, one thing I'll just suggest here is almost like doing the problem without looking at the answers, which is okay. -3, 2 is there, 0, -1's there, 3, 1's there. So it's got to have some sort of a shape like that. Now that eliminates B for sure. Okay. And then you get down to, yep, it's got to be D. Um, like how could this look? Well, it could look a lot of ways, but um, the thing with A is that it doesn't actually go through the points, which is kind of odd that they didn't choose it to be closer, but maybe they're hoping you would just go through the first two and then do that. Okay, I really apologize for the size of some of these graphs. They're just not that large. I know there's a zoom feature on the Zoom.
If
That may
it's,
help,
oh,
but just
okay.
if those aren't visible, let me know.
No, that's good.
I'll be right back with you. All right, I am back. Let me know if you have any questions or an answer.
Is it D?
So the way to do this one, it's usually to go through here, right? 0, 2. That eliminates only one of the graphs, right? Just eliminates that one. And then the next thing is to look, nearby points. So like again, like you could, and I'm not saying you need to, like you could try to graph this without looking at the graphs just to get a feel. Like, okay, that's up there, that's down there, you know. So it's got some sort of a like something like that. And that could get you closer to figuring out which one it is. It's down to A or D. It is D. Okay, now the other type of graphing problems that you see, let me make sure that was the last of those. Yeah. The other type of graphing problems that you see is, and you may see this in your course at some point, is going backwards. They give you the graph and you have to write the factors. And the way to write the factors is to figure out where it either touches or crosses the x-axis. Do you remember that from a previous course? Do you need more explanation on that?
Yeah.
Do you want to try this one on your own, or do you
Um,
want some more explanation?
is it A?
It is A. No, it is not A. It is not A. Why is it not A? When you multiply this out, I shouldn't do that. When you multiply x times x minus 2 out times x plus 3, you end up getting x cubed. And a cubic starts low and ends high. This one starts high and ends high. So this has to be an even degree. Now there are like 4 graphs that you have to remember. Let me see if I can draw those 4 graphs here. 1, 2. All right, so the first 2 are for even degree. Starts high, ends high, starts low, ends low, odd and odd. Starts low and ends high, starts high and ends low. So the even ones is when the leading coefficient is positive, leading coefficient is negative, leading coefficient is positive, leading coefficient is negative. Do you remember seeing these 4 graphs at some point?
Yeah.
All right. So what that means is the um, graph is based on what's called the power term or the leading term. And it comes from like, well, what is x times x times x? That's x cubed for A. For B, it's x squared times x, which is x to the fourth. And C is x cubed and x to the fourth. So but you know, based on the zeros, it's down to A or B. So the only difference is this leading coefficient.
Should be
Um,
B.
it would be B, yeah.
Can you explain the x cubed thing again?
Yeah, it's x times x times x. X. If you were to multiply them out, like you don't care about the rest. The rest is whatever it is. The leading one is what's called the leading coefficient of the power term. And you get that from multiplying just the x's and whatever power they have with them.
Okay.
All right, so there's a bit more to that, and let me show that here in the next answer space. So there's a next kind of thing here, which is like for A, there's an x from here. This squared goes with that x, so it's x squared, and this squared goes with that x, so it's x squared like that. So this is x to the 1 plus 2 plus 2 x to the fifth. Does that make sense? How we got that?
Yeah.
Like if you're to expand all this, right? Like this middle one expands out into an x squared plus some other stuff. This last one expands out into x squared plus some other stuff. So you just multiply the leading ones there. Right now, the
Could you
go ahead.
what would the graph look like for x to the power of 5?
So let's get to that. These numbers on the top are the multiplicities. You might want to rewatch the video of, well, hopefully I won't get it posted in time, but I just did a lesson on this with a student like last hour. Exactly this. The multiplicity tells you whether it crosses or touches. So an even multiplicity means that it touches, and an odd
Hmm.
multiplicity means that it crosses.
Okay.
Right. And that's how you answer this question. So let me reframe the question. So these are all end up being degree 5. Actually, I'm sorry, they're not all degree 5. Some are degree 4. First one is degree 5. Well, there's a bunch of ways you can do this. The zeros here where it touches. So at -1, it touches. At 2, it touches, and at -3, it crosses. I don't know why I did them out of order. Probably because I'm tired. But this is x plus 1 to the power of 2. This is x minus 2 to the power of 2. When it touches, it's an even exponent. When it crosses, it's an odd exponent, x plus 3, like that.
Okay.
So now that helps to figure out which one it is, which is the correct answer.
Deep.
Yeah. All right, let me quickly look for a few more of these. It's always hard to find multiple choice. The hardest stuff to find. There's plenty of problems like this, just not any with multiple choice. Okay, we'll just have to keep going. All right, next thing is just another polynomial graph here. All right, something a little bit different, which is kind of what we started out looking at. Go ahead and let me know what you come up with.
Oh, D.
All right, so f of x equals 0, is that the x-intercept or the y-intercept?
Oh wait, no. It would be one. I mean C.
Yes. Very easy though to add that, to use that answer. I'm surprised it's not A. Frankly. But, okay. Again, sometimes these look really difficult and they're not. A lot of questions fall into this category. Take a look at this one here.
I'm kind of confused on how to solve this.
What kind of a line is this? Like, let's say it's f of x equals 1 or y equals 1. What kind of a line is that?
Uh, a straight line with a positive slope.
The horizontal line.
Oh,
Horizontal. So y equals a number is horizontal. This one has one solution. That's the hint. That horizontal line, like let's say letter E was 1, would not be correct. We want one that has 3 solutions.
so
Let's say it was A. Let's draw a line at y equals 2. How many times does that hit the graph?
once,
Okay, so that's out because we want it to hit 3 times. How about at 0?
once,
Okay, and then at -2,
once,
and then at -3.
3 times.
There you go. Now that you know what to do you agree that it's not a difficult question,
Yeah.
but it looks difficult? Or it has the appearance like, what do I do? Yeah, I mean, it's a lot of the questions fall into that category. Really do. Okay, I don't know if we've done any of these in a while. All right, let's do some solving exponents, though, solving with exponents. All right, take a look at this. Let me know if you have any questions or want any of the properties before we get started. Put in the chat properties of exponents that might be useful.
Is it C?
So how do you go from x to the 8th to x to the 24th? That's the question. And the answer is, I'm not saying you're right or wrong yet, it's x to the 8th to the power of 3, because you end up multiplying those exponents.
Oh, so it'd be 2 to the power of 3.
Yes.
So D.
Yeah. Let's put up another question here. This one requires a bit more work, but the exponent rules do help here.
Is it B?
So the negative exponent, this is one of those things not sure where this starts, but what it does is it puts it on the bottom. So it actually the negative exponent never affects the sign. Never affects the sign. So the next thing is like, well, what is this a to the 1/2? Well, it's really the square root of a. Okay. So that's thing one I want to just point out here. Now we're solving for x. So how do we do that? Well, we have to undo this exponent over here. And you can undo it with the power of -2, both sides. -2 times -1/2 is 1, a to the power of 1. X to the -2 is 1 over x squared. The property is x to the minus n equals 1 over x to the n.
Oh, okay.
Right? Here is one that's kind of like that, although it's not multiple choice. Let me see if I can find another one of these before we move on to the other type of solving. They do tend to throw in something like that. All right, this one's kind of something we can do. You will see one exponent question on your test. I mean, it could be way easier than this, could be way harder, but these are like this is all I'm finding here. I not find the true exponents. Take a look at this. See if you can come up with that.
So I have a squared plus b minus b squared equals 16, and then a plus b equals 2.
Yeah, now is there a way to factor what's on the left here?
A plus b, a minus b.
That's where the a plus b comes in. So this whole thing is 2 and a minus b.
Oh, so it'd be 8.
Yeah,
Okay, that makes sense.
right. Like I wish I could give you one like exactly like that. Of course, I can't, but there's kind of one like it here. So I'll put this one in. This is a free response question.
D equals 2.
Good. So the factoring, you still gotta know your factoring. All right, here's kind of a different question, different take on some of the things we've been doing.
Is it D?
So the solutions to this are what and what? What are the two solutions?
I mean, if you do x minus 3 equals plus or minus, I mean, 9.
Right. And so
So then it would
yeah,
be
go ahead.
minus 12 and then 6.
3 plus 9, 3 minus 9. I think you had a sign error somewhere in there.
Oh, so then 12 minus
What
6
did,
is 6.
yes. So let's try another one here. Do the same thing. The sum of the solutions. No multiple choice here. So let's go x plus 4 squared equals let's go 64.
Four, 4 and minus 12.
Okay, so what does that add up to?
Minus 8.
Yeah, good. All right. All right, so this is a take on problem we've done a few times. We talked about this idea that you can only take the square root of certain numbers. Okay. However, this problem here asks you for the solution of this, not this. Okay. Or not x. It's asking for the solution of x minus 3. What is the root of x minus 3? Not x. So in this is a little bit odd one, but if you set each of these equal to x minus 3, you can solve for x. You can find here that x is 4. You can solve, and you kind of like, let's choose the ones that are nice, first of all. This is now it's x equals 6, okay? And this one down here is x equals 12. Which of these can you actually take the square root of? Can you take the square root of 4? As it a known value?
Um, yeah.
Yeah, so these are okay, but these are not. Like, you can't take the square root of this, just like get those away. Go away, okay? Because you can't take the
Mhm.
square root of 6. I don't know what that is. I don't know what the square root of 12 is. That's probably not going to be it. 4, though, when you put 4 back in, does this work? Is the square root of 4 minus 3 equal to 3 minus the square root of 4?
Yeah.
It is. Now let's just say that one didn't work. Well, then you know the answer was B. So as a reminder, sometimes you can just get it down to a couple of answers and then move between them to answer that. All right. One more reminder here on the free response. You'll notice it always asks for positive solutions. Free responses are always positive. Always, always, always. You'll never get a negative. You might get 0, but never a negative. All right. So some final thoughts for you for taking